Hello, we are going to continue with the graph drawing the curve of quadratic equation while using the table method. We initially said that in our function f of x equals to 2x cubed plus 5x plus 3, we said here that in this function the domain of x will be from negative infinity to plus infinity. I said that at 0, x equals to 0, the corresponding y will be 3. And the corresponding at x equals to negative 5 over 4, the corresponding value of y will be negative 1 over 8. Negative 1 over 8 is inferior to 3 on this graph. That's why it's down here. Now, I said in this interval negative plus infinity to negative 1 over 8, you can see back to your gradient function. The gradient function, you can take a negative value there, and I can take an example, negative 3. Negative 3, when I substitute here, I'm going to have a negative. So there's a descending value here. Now, after having a descending value, I ask myself, what is found between negative 5 all over 4 and 0? Between negative 5 over 4 and 0, the value which is found here is negative 1. I substitute again in my gradient function. When I substitute my gradient function here, I'm going to have negative 1 here. 4 is given negative 4 plus 5. It gives me a positive value. So here will be a positive value. So the gradient is increasing from this point up to this point. Now, at 3, between 0 and plus infinity, I can have 2. So I can substitute or 1 here. The value here will be positive. So at this interval, I still have positive. So it increases still. So we see how when I have my table as such, I immediately have the same graph. You see, as x is toward infinity plus negative infinity, you see that as x tends toward its negative infinity, the y tends toward its plus infinity. I have directly the graph on this side with a negative gradient descending as from this side to this side. Now, at this point here, negative 5 all over 4, you have your turning point, which is the line of symmetry in our first way method of calculation that we did, which is the quadratic method. Now, when you have traversed this line of symmetry, you find yourself at this portion. At this portion, between here and here, you have a positive gradient, so it's increasing. And cutting again the line y equals to 0 at the point 0. It's cutting the line because here at this point, it's instead cutting the line of x equals to 0 at point of y equals to 3. So, and you have your graph which is formed. Lastly, we are going to have another thing again in curve sketching of quadratic functions. The last part will be how to transform quadratic functions. Now, the first method in which you involve in the transformation of quadratic method will be by f of x plus or minus a. If you have f of x plus a, you need to ask yourself a question. If I have my graph as such, anytime I have a curve of x of x plus a, I need to know that there will be a shift on the horizontal line. If there's an addition of a on the x, there will be a shift on a horizontal line. Now, the shift when it is x plus a, the shift is toward the left. And if it is x minus a, the shift is toward the right. Again, if I have f of x plus a instead, the shift will be to upward. But if I have f of x minus a, the shift will be downward. A good example here, we had f of x equals to 2x cubed plus 5x plus 3. Now, if I have f of x plus 3 is going to be 2x cubed plus 5. It's going to be instead 2 into x plus 3 cubed plus 5 into x plus 3 plus 3. Now, I have to ask myself the question, if they are asking me to find the curve that this is going to produce, for me to find the curve that is going to produce, I'm going to go back again behind. I know that there was an x plus 3, so the x plus 3 is going to cause this curve to shift 3 units to the left. So I'm going to shift 3 units to the left and put this -1, 3 units here, this one here, 3 units here, and this one, 3 units here, and this one, 3 units here to have my new curve. So this marks the end of quadratic equation. I'm really glad you've heard everything I've said. Thanks for your kind attention.